Hi everyone, we'll continue our practice session on regular expression elements in this video. In first part, we covered literal characters, syntax or special characters. We looked at ASCII and Unicode usage and tried out escape sequences. In this part, we shall go over wildcard, character classes, character groups, and backreferences. So pretty interesting stuff coming our way. So we'll start with wildcards. So dot or period character is considered a wildcard in regular expression terminology and it matches any character whether it's digit, letter, special character, just anything. It even matches new line or line terminators if S or dot flag is set. Otherwise, those are the only exception to its unlimited matching power. It is generally used with quantifiers. So let's see for ourselves how it works and head over to regex101.com. So let's start with a rather crude example. So I'm going to say hello dot 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 dot. How are you doing? Okay, so now we can substitute this these dot 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 with any four character names. So hello John, how are you doing? And see it starts matching. Backslash is required to escape question mark, right? All right, so this can be John, this can be Paul, this can be any four character word. So, but why restrict ourselves to four characters? We can use this dot with wildcard, right? And um, so if I do dot static, then we can use larger names, different, or anything in between. So dot static is going to continue matching whatever we throw at it, like any characters, numbers, special characters. It would keep matching anything that we throw at it, even spaces. But the only exception to the rule is new line, which would only work if S or dot all flag is set, which is set at the moment. So if I turn it off, then it would stop matching because the new line is the only exception for this dot matching ability as we discussed. So dot or single line flag is required to for dot to match the new lines as well. I think that is enough for wildcard. We have a lot more to cover. So let's head over to our character classes. So a character class specifies a list of characters between square brackets and matches any character in the list. So as we discussed in concepts video, the list can be compared of a single character where the character matches itself, a range of characters specified by a dash, escape sequences like backslash t, w, character class escapes, etc., and a combination of all of these. So let's head over to regex101.com and get some real feel of how it works. So I'm going to get rid of all this and let's start with the absolute basic. I'm going to specify the simplest of character class ABC in square brackets. And if I type ABC, we see it matches. But that is not the same kind of match as ABC without square brackets. Notice the difference here. It's one match. The entire regular expression matched with the input string entirely. But with square brackets introduced, there are three different independent matches, right? And why is that? Because we can see the explanation. ABC in square bracket match a single character present in the list, right? So A matches A in the list, B matches B in the list, and C matches C in the list. This is how it's working. So there are three matches independent of each other. All right, so now we know that characters can match any character in the character class, but we can also have ranges. So this ABC can be written as A to C or A dash C. And now it would match A, B, and C because B falls in between A to C. So the most widely used character class you can say is A to Z, A to Z. You would see that a lot if you continue using regular expressions. So now it would match any alphabet we throw at it. So if let's say I say hello world, it is going to match all the letters in hello world because they all fall between here. It also match hello world. So as you know, regular expressions are case sensitive by default, so this character class is going to match both small and upper caps letters, but if I just restrict it to small a to z, then the uppercase letters are excluded. Right, we can do combinations of both of these. So a good example can be, so if I get rid of all this and say this game can be played by 2, 4, 6 players. Now, if our game can be played by 2 players, 4 players, or 6 players, then we can use this regular expression to specify the same. So if I do this and now I can type 2 players, 4 players, 6 players, but not 3 players or any other number, right? So, but for 2, 4, or 6, this is going to be a valid match. We can also use escape sequences in character classes. So, for example, if I say I'm going to match all the separators in the sentence, so I can say \s, which matches spaces or white spaces, dot, comma, dot, or dash. So now it is going to match dot spaces. I can say 2, 4, or 6 players. And you can see it is matching all those characters that are specified here, including this backslash, which is matching the spaces. Right? I can also introduce backslash D in here, but it's now thinking that I tried to specify a range, so I need to escape the dash character with a backslash. And now this is also going to cover any number present in here. So rather than doing 2, 4, or 6 alphabetically, I can say 2, 4, or 6 players, and it matches numbers, dots, commas, and dashes. We don't have any dash here, but if we had, it's gonna match it as well. All right, since we are on topic of ranges, this can be used in a variety of ways. So I can say A to Z ing, and this would match John is a wonderful king. He wears a nice ring. He can even sing. See how it's doing? So we can do a lot of interesting stuff with our character classes this way. All right, so this I mentioned that the most important character classes you're gonna come across is A to Z, A to Z, and we also have another variant which is 0 to 9. So this is a character class for any alphanumeric character. So it is going to match any number or letter. So, and this 0 to 9 can also be substituted by backslash t, of course. So you can use the range or anything. We could also use ASCII characters or Unicode numbers here, and the range would just work fine. Another interesting aspect of character classes is that they can be complemented. So they are kind of like a set of characters that can be matched. And if we consider it a set, then a set can be complemented. So a complement of a set is defined as a set that contains elements present in the universe that are not part of the set. So if we go by that definition, then if I do a complement of this set, which is done by introducing a cap sign at the beginning of our character class, then this character class means match everything that does not belong to this set. Right, so now as you can see, previously it was matching all the alphanumeric characters in this sentence, but now it is matching anything but alphanumeric characters in this sentence. So dot spaces, etc. Everything is being matched except alphanumeric characters. Now let me introduce another interesting concept of character classes, and in case you are forgetting, this video is about regex elements or atoms, which are basic building blocks of regular expressions. And so any regex operators can be applied to them. Now character classes are regex elements or atoms, so we can apply, let's say, quantifiers on them just like we can apply quantifiers on an individual character or syntax character. So let's see that in action with our already discussed example. So if I reduce this regular expression to ABC and introduce ABC here and introduce a plus sign on the right, which is the quantifier to match the previous token between 1 and unlimited time. So this ABC in square bracket is a token or regex element. So now you can see the difference here. It is one match again. Remember, without this plus, there were three individual matches, but with plus, this entire thing matched because the regular expression evaluated this entire input string and found it matching with this whole regular expression with this plus quantifier. So this is a really powerful tool you can use in a lot of ways. So let me come up with a very basic example. So let's say I want to write a regex that matches hexadecimal characters. So what I'm going to do is I'm going to say \t and A to F, and here I can say, let's say 3A, and it is matching 3, we can say 7G, and it's not matching, but it partially matched, so we can fix that by introducing cap here and a dollar sign here. So now it would match entirely or fail entirely. So if I do it 7E, then it matches. So so you can put these concepts to use in a ton of ways. I just introduced one example, and let's head over to the next concept. So we saw the complement operator in action earlier, which created a negative or complement set that would match anything but what is specified in character class. That was a widely supported operator applicable in most flavor or parsers of regular expressions. A very limited supported feature is intersection or subtraction operators, which we are going to try next real quick because they are limited support. So let me head over back to regex 101 and quickly type it. So do this A to Z and then intersection operation using double ampersand, and I say a complement set A, E, I, O, U, all the vowels. I close all of these and A, B, C, D, E, F, G, H, I, J, K, L. Alright, so you can see it is matching everything except vowels in my input string. But the real problem is right here. We are in Java parser at the moment, but if I select any other parser, this won't work. So if you work with Java, you have these interesting tools available, but if you are working with any other language, tough luck. So that is all we are going to cover for this because this is very limited support. So let's head over to our next concept, which is capturing group. So a capturing group's a subpattern allowing you to apply a quantifier to the entire group or use disjunction within it. Right, so what it does is you just use these parentheses and provide a pattern in between, and then it creates a regex element or token or atom on which you can do all sort of operations like you do on any other regex token. So let's head over to Regex 101, give it a try. If you have ever seen a Christmas time movie from Hollywood or something which depicts Santa always coming up saying ho ho ho, we can actually come up with a regular expression for that ho 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 part. So to do that, we can create a capturing group using parentheses and type O backslash S. So O and then a space, and then I close it and specify a quantifier, a rigid quantifier of 3 times repetitions. So now if my input string is and says oh, 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 right, then it is only going to match this part of the input string, which is who repeating 3 times. The fourth one is excluded because our quantifier does not allow it. Otherwise, it would have captured it as well. So now the interesting part is you can see in the match information, the match one is for the entire input string what matched, but the group one is showing the value that was captured by this capturing group. We call it capturing group because it captures and returns a value for the match that was done by this capturing group. And since this was repeating 3 times externally, so it is only giving you the last capture that it was able to do. It is one value. So any later matches for this capturing group, like in this case, since who was repeating 3 times, the last match overrode the previous ones. All right, that is going to be clear in examples later on. So let's quickly go over some very practical examples that involve capturing groups. So now I'm going to use a very complicated one, and let's see if you can figure what I'm doing here before I finish and type the input string. So, okay, can you guess what this regular expression does? You might want to pause and think. So now I'm going to type the input string that it works with. And yes, this is a regular expression to match a date, which is in YYYY MMDD or YYYYDD MM format. And the interesting part is that, as I was explaining before, each capturing group in the regular expression captured its own value and that value is made available in form of these groups in the match information. So as you can see, the first capturing group marked by the first opening parenthesis and its closing counterpart captured the year, and this is made available in group 1, 2024. The second capturing group captured the month, and the third capturing group captured the date. So this is really powerful if you want to use regular expressions in programming, let's say, because you can parse an input string and get the matching information for its individual constituent parts, just like this date. As the user types, you are not only making sure that it is matching, you are also getting the sub match information extracted from that successful match. In interest of time, let's move forward. Let's play around a bit further with quantifiers. So I say a character class enclosed in a capturing group and a quantifier applied on it, right? And here I say ABC. The interesting thing that I've created this example for is that the group one the only capturing group in our regular expression captured the item B. Again, why? Because AB matches either A or B in the input string, and there's a quantifier on the capturing group itself. So it is going to match A in the first attempt when it is processing A from the input string, and then when it tries to process B, it also matches and overrides A as the captured value for this capturing group. And then C does not match, so the return value for this capturing group is B because it overrode the value A. So now note that capturing a value and retaining it and processing it is a memory and processor intensive operation, not for likes of these basic examples, but as the regular expressions you use grow more complicated, then the performance impact also increases. So you can avoid that by using non-capturing groups, which are used by introducing a question mark and a colon in the beginning. And this time you can see it stops capturing the value. It is just applying the quantifier It is still applying the quantifier on the capturing group, but it is a non-capturing group now, and there's no value captured or processed. So let's go over another example to make the point clear. So let's say we are trying to write a regex which matches image file names with different extensions. So let's say I say, in fact, let me first type the possible matches image.png, image.bmp, etc. So now if we want to write a regular expression that capture all these file names, we can do it using regular expression group. Let me get rid of this, and now we say png or jp question g, which would capture both jpg and jpeg, and we can say bmp gif webp, etc. So now this should match all of these file names if I introduce this literal dot, and as you can see it's working. And since it's a non-capturing group, it did not capture any value for this group. But having parentheses available did allow us to group these disjunctions or clauses together in one compact format. All right, let's take one more example, and we'll this time use a named capturing group. And a named capturing group is a particular kind of capturing group that allows you to give a name to a group. The group's matching result can later be identified by this name instead of by its index in the pattern when we use backreferences. So let me type in. So let's say I say, and the naming convention is we use question mark followed by the name for the group. So let's say I say first name and then dot static and then space and then question last name in angle brackets dot static. Okay. So now we can have different names like John Smith, Jane Doe, John Doe. Sign applied, and we're going to get rid of this dot all flag, so each line is considered a different one. So now you can see it is not only capturing the values but also giving us first name John, last name Smith, first name Jane, last name Doe, etc. So name capturing groups are really good. If you remember from our video on backreferences, it allows you to use this first name and last name in backreferences compared to \1 \2 as the group's captured value. So our next topic of discussion is backreferences. But before that, let me quickly revisit our date regular expression example, show you how the captured values could be. So there was some ambiguity whether it was in MMDD format or DDMM format, so that would go away with this. All right. And now if our test strings are 20240105, see, group year is 2024, group month is 01, and group day is 05. Similarly, if we have another example, 20210630, then we would have information for that as well. All right, the last concept that we need to look into for examples is backreferences. And a backreference refers to the submatch of a previous capturing group and matches the same text as that group. So a capturing group captures and returns a value for itself, and that can be reused later in the regular expression as a literal matching element later on in the regular expression. That won't make much sense with words, so let's go to Regex 101 and try some examples. So let's say I come up with a very basic one, A or B or CD \1, right? And it is going to match AA. How? Because A or B or CD captured the value A. That captured value A was reused by using \1, and \1 refers to the first capturing group in this regular expression. So there's only one. So \1 is going referring the captured value of the first capturing group. So the first match was done using this group, and the second value was matched using the A value, which was the captured value for this group. All right, so this would not only match AA but also match BB or even complete repetitions like CD CD, right? Because CD was also a possible match here. All right, let's go over a more advanced version of this. So let me type the regular expression first and then I would explain. So I say a word boundary followed by a, an alphanumeric word, right? Followed by a space or as many spaces as you want. And then we refer back to the capture value of the group, \1, and then we close the word boundary or find the closing word boundary. All right. Can you guess what this regular expression is for? Well, this regular expression is for repeating words. It detects repeating words. So, revisiting our previous example, Santa says, ho, ho, ho. It didn't work. Something is wrong. Oh, I forgot the backslash here. All right. So it is going to detect any repetition once. So I went to the library. See, it is going to capture every such repetition because, and what's going on here, it captures the start of a word and then after the start of the word, using the word boundary, it uses this alphanumeric matcher and with this plus quantifier grab all the words in between the word boundary and the space character, and then it again refers to the value that was captured using this W plus, which in our case is O and the in the case of our second example, and uses it as \1 again, right? And then the word boundary ends and it detects whether the two words were repeating with a space in between. Okay, let's go over one last example. So we type the examples first and then we are going to write the regular expression. So we have many cases where we use single quotes or double quotes interchangeably. But let's say we want to detect the value even if it is enclosed in single quotes or double quotes, like, for example, a book title. I hope I got the spellings correct. All right. So let's come up with the regular expression. So the regular expression, and this time we are going to use a named capturing group. So let's say we say quote and then followed by the possible quotes. So we say single quote or double quote, one of them, right? And now we can close this capturing group, and as you can see, it is already starting to match the individual quotes. Now we need to match the pair with the second one. So now I say dot static question. Now I close it and I say \k and then quote. So what happened here? Let's dissect. So this first capturing group is going to match the first quotation that it encounters in the input string. So in this case, it's going to capture a single quote, and in this case, it's going to capture the double quote. Then it is followed by this part, which matches anything between the starting quote and the ending quote. And so in first case, it's going to match Tarzan stories, and in the second case, it's going to match Jane's memoirs. And then we use the notation dash \k followed by, in angle brackets, the name of the capturing group that we are referring to. This is quite similar to using \1 \2 for named references, except using the number to identify which capturing group we are referring to. We use \k to denote. We are specifying the group with with a particular name, and then in angle brackets we provide the name. So this whole thing would resolve to the same captured value for the group with this name. So in the first case, the value was a single quote, so it's going to become a single quote here, and it's going to match the entire input string. And in the second case, the captured value for this group was this double quote. So this part is going to resolve to a double quote, and it's going to match the entire title for that book. All right, this brings us to the end of our video. I hope you enjoyed and learned how to use regular expressions, capturing group, character classes, and back references using those examples. Examples like pictures are worth 1,000 uh, concept words. So I hope that was more practical than the concept videos we have seen so far. If you liked, please do give a thumbs up and share the video and consider subscribing to the channel. Thank you so much for watching.